Let's take a few minutes and discuss scalar multiplication or the dot product. What we're looking at here, and we will, as we go through, give more significance and meaning to some of these things. But from a mechanical perspective for us right now, we're going to say the dot product of some vector A, which we're going to define as A sub xi plus A sub yj plus A sub zk, and vector B, which we're going to likewise define just using B's, so that the dot product of A and B is a scalar. Sometimes this is what we refer to when we're calling the scalar product, or scalar multiplication. It's AX BX plus AY BY plus AZ BZ. So in this case, with two-dimensional vectors, the scalar product, the dot product, is simply going to be 3.5 times 7.2 plus 8.1 times a negative 4.6. So 3.5 times 7.2 is 25.2 plus an 8.1 times a negative 4.6 is a negative 37.26. So that's going to give us a total of a negative 12.06. Since these are just two significant digits, we're just going to leave that as a negative 12. So this one I'm going to work through A, and you can work through B and C. If you have any questions, you can ask in class or email me. Alright, for UV, U dot V is then going to be 1 times 3 plus a negative 2 times 1 plus 1 times negative 2. So that's 3 plus negative 2 plus negative 2, which is going to give me a negative 1. So I'll leave B and C for you to practice on. Now there's another form of vector multiplication commonly referred to as the cross product, but more formally referred to as the vector product. I'm going to show you more of a shortcut on that one rather than a formal mathematical explanation. They're out there. Feel free to look for them. But given two vectors, A and B, defined the same way, AXI, AYJ, AZK, and BXI, BYJ, BZK. The shortest way to find, or maybe the shortcut way to find it, is to make use of a matrix type structure, I, J, K, and we are going to replicate the I and the J again. AX, AY, AZ, AX, AY, BX, BY, BZ, BX, and BY. That's just a matter of writing. Again, this is a more mechanical way. This is not a mathematical explanation. If you simply draw the diagonals, and some of you may know where this is going, then you have AY, BZ, I plus AZ, BX, J plus AX, BY, K, and then we're going to subtract from that and I often will tell people to write these down, put a great big parentheses and stick that negative sign in front. So we have AY, BX, k plus azby plus axbzj. Again, I'm not giving you a whole lot of mathematical explanation as to what's going on behind this, but this will allow you to calculate the vector product. We won't do this type of thing very often, but we will need to go to 3 dimensions for a few particular topics. So if you have a pair of vectors that look like this, so what I'm going to do is I'm going to use that exact same method that I just showed you. I, J, K, I, J. 3.5, 8.1, 0, 3.5, 8.1, 7.2, a negative 4.6, 0, 7.2, a negative 4.6. So this gives me 0, 8.1 I, 0, 7.2 J, plus 3, a negative 4.6, 3.5 K, and I'm going to subtract from that 7.2, 8.1 K plus a negative 4.6, 0 I plus a 0, 3.5 J. Now many of these terms, because these are two-dimensional vectors, they simply go to 0. So we're left with the negative 4.6 times 3.5, which gives us a negative 16.1 K, minus 7.2 times 8.1, which gives us 58.32 K, or 74.42 to negative K. This is another one of those areas that's a little fuzzy with regard to significant digits. I'm simply going to tell you to maintain what you have in the problem, since this is a form of multiplication. Everything involved here is multiplication or addition. And so in this case, I'm going to say it's negative 74K. One little sneak preview is you will notice that these two vectors both lie in the XY plane, and the vector product is all K. So that means it's all going to be perpendicular to what's going on there. We'll practice one of these just like we did before, and then I'll let you practice them on your own. So for A, we have I, J, K, I, J. 1, negative 2, 1. And then it's still going to be a 1 and a negative 2. And then 3, 1, negative 2, 3, 1. So I draw my lines. That's going to give me a 4i, 3j, plus 1k, and I will subtract from that a negative 6k, 1i, and a negative 2j. So we can simply flip these signs in here. 4i minus I is 3i, 3j and 2j is 5j, and 1 plus 6 is 7k. So this is A. I'll leave B and C for your practice. Now let's talk about projectile moment for just a second to start getting you up to speed on that one. So first of all, the idea with projectile motion is simply an object that we commonly call a projectile is moving under the influence of only gravity. We typically will be ignoring air resistance. The object itself is called a projectile. So if we have something that says a panther leaps perfectly horizontally from a 5-meter high perch at a speed of 5.25 meters per second, how far from the base of the perch does it land? Well, what happens is if this is where it starts, it's going to physically follow a path that looks like that. It's a parabolic path. Sometimes projectile motion is referred to as parabolic motion. It starts out at a height of 5 meters, and we're asked to find out how far it goes horizontally. The motions, horizontal and vertical, are completely independent with one exception: time. The time that it takes for the panther to move downward 5 meters is the same as it takes for the panther to move horizontally some distance that we don't know, but we're trying to find. So essentially we use two separate types of motion that are simply connected by time. So vertically, okay, we have a displacement, a delta y, of a negative 5 meters. It's going from 5 meters down to 0. We have an initial velocity vertically of 0 meters per second, and I can say that because the initial motion is completely horizontal. We have an acceleration, which is gravity, which is about a negative 9.81 meters per second squared. I need to find how long it takes for this thing to hit the ground. If I do delta delta y is 1/2 at squared plus vit. Since my initial speed vertically is 0, this term is gone. Then this tells me that a negative 5 is equal to 1/2 negative 9.81 t squared. Negative 5 is equal to negative 4.91 t squared. T squared then is going to be just a little over 1.02. And so t is effectively 1.01 seconds. Now, some folks may be wondering, well, wait, shouldn't this be plus or minus? Well, if we consider something going up and coming down, the full parabola would have a horizontal or an x-intercept at the point of negative 1.01, but that happened before, and it's really not part of this problem. This is really just half that parabola. Now, moving from that, the horizontal motion. I'm looking for a delta x. I know that my initial speed horizontally, my initial velocity is 5.25 meters per second. My acceleration horizontally is 0. Gravity only operates up and down. My time is 1.01 seconds. So if I were to go back to the same idea of delta x is 1/2 at squared plus vit, in this case, this term goes to 0. So delta x is simply a speed, which is 5.25 times the time, 1.01, which gives us a horizontal displacement of about 5.3 meters. We have two decimal places, or two significant figures, for the height of the perch, so we would want two significant figures for the displacement, how far it went horizontally.